Okay, Year 11, welcome to your video tutorial today on algorithms. We're actually going to, sorry, it's meant to say syllabus stop point, but we're actually going to skip ahead a little bit in the syllabus and actually look at structured algorithms. So last lesson you were having a look at data types and the different types of data. But the next logical thing is, okay, with those variables in those subroutines that hold those different data types, how can I kind of control the logic in order to be able to execute what I am trying to in that subroutine? So an algorithm is how I do it. You might remember we're on 8.2.1, understanding the problem, planning and designing. You also might remember that I've said multiple times in the past, we are not coding yet. That is because the first thing before you start coding is planning out your logic. And welcome to where, some of the pieces will start to come together, which is planning using algorithms. So an algorithm is a set of steps. It's divorced from any programming language, and it's the planning out of logic in basic English. Now, there are some conventions that I need to use with planning out logic, and there's two ways in which I can plan that out. The first is with a flowchart, and the second is within pseudocode. So today's video tutorial is going to focus on the one that we use more, which is pseudocode. What I am going to draw your attention to is that all of this is also explained in the course specs doc, which I'm going to attach. So it starts from here, page 34, methods of algorithm description, and it actually gives you a whole lot of detailed information on how you can actually write out the logic for all of the different control structures that we're about to look at in terms of algorithms. So if you would like, I'd probably recommend having page 34 onwards in your course specs docs open, just so you can use it as a reference guide. Like I said, however, even though the course specs document shows flowcharts and pseudocode as the two different ways of representing algorithms or, logic in basic English, today we are just going to look at pseudocode for this tutorial. So, how do I organize logic? Well, the logic or the steps that I wish to, execute in a subroutine are controlled by these things called control structures. And they present themselves in three possible ways. So one way in which I can control logic is in a sequence, one way in which I control logic is in a selection, and the other way in which I can control logic is in a repetition. Now for selection and repetition, for number 2 and number 3, there's a couple of branches off that. There's a couple of different types of selection and there's a couple of different types of repetition that we're going to go through today. But first and foremost, the sequence control structure is really easy logic. So my subroutine starts, I do one step, I do another step, I do a third step, and I end. No matter what happens in that subroutine, no matter what's going on, it's just step 1, step 2, step 3. Now, I might only have 2 steps in a sequence. Again, this is an example. I might have begin, step 1, end. That'd be pretty rare, but I could have it. Or I might have begins, step 1, step 2, end. Begin, step 1, step 2, step 3, step 4, end. Anyway, if that's the way I want to have my logic, just in basic steps, one executed after the other without any divergence off from that, that is a sequence control structure. A selection control structure means that my logic for my algorithm is controlled somehow and one or more pathways are selected. So binary selection one pathway is selected from from 2 or many options. Sorry, let me say that again. The selection control structure will control logic and will present pathways. That might be 2, that might be multiple, and the logic will flow depending on a number of conditions through one of those pathways. So the selection control structures involve binary selection, that's when there's 2 options and it's the simplest, or multi-way selection when there's more than 2 options. So let me show you what that actually looks like. For a binary selection, maybe I might not necessarily want sequence step 1, step 2, step 3 executed regardless. Maybe I might want to control my logic and say, okay, let's start if something's true, then do this, otherwise do that. So I might want my logic to be controlled. I might want my logic to say, okay, I don't necessarily want step 1 and step 2. If condition is true, then do step 1, otherwise do step 2, and then end. That's called a binary selection. Now you'll notice this word that we're using with binary selection is if and then else. You'll also notice that this layout here is done really on purpose. So it's really important that you follow these same conventions. So I begin and I end at the same indentation. My if statement begins if and ends if at the same indentation. So if whatever is true, then, and then I indent for whatever I'm doing. Else goes back to the same indentation as the initial if, and then process 2 goes down, and then I end. So that's basically the selection, the binary selection control structure, and it will mean that my logic is able to select one of 2 pathways. Multi-way selection is a little bit different. Again, it's going to be the same as multi-way selection in that one path gets chosen to be executed. However, what I'm allowed to do with a multi-way selection is I'm allowed to, instead of just being able to choose from 2, I can actually choose from multiple. So there's 3 here in the example, but I could choose up to 5, 6, 7, 8. So I begin, I input a value, so I take some kind of input from my user, and then I say, okay, the case where that value is, it might be 21, it might be between a range or it might be a hard-coded value. The best example I could give you is, like bands, 49, 50 to 59, 60 to 69, 70 to 79, do something. So the case where the value is, within a range or at a certain point, do this. Within a range or at a certain value, do that. Within a range or at a certain value, do that, and then end. So only one of these is executed, and then it ends. As soon as it selects one of these, it breaks out and goes, okay, that's it. It does not repeat. It does not loop. It goes, okay, that's the value, and now I'll jump out. So same with this one. If the condition is true, it only checks it once, it doesn't loop, it executes that, and then it jumps out. Okay, repetition or iteration is a bit different from selection, and that's actually where you can get something to repeat a number of times. So unlike our selection, binary selection or multi-way selection, which just chooses a pathway and ends, repetition will actually allow something to be executed multiple times. I can have that as a pre-test, a post-test, or a counted repetition. So let's have a look at what those will mean. A pre-test is where I can test the condition at the start. So like the others, you'll notice something that we have in common. We have a begin and we have an end. But unlike my binary selection, which used if, unlike my multi-way selection, which used on the case where, this one uses a condition, a word called while. While is exclusive to a pre-test loop, and it's the words that you have to use. Again, the indentation you'll see is consistent, and this is something that you have to make sure you adhere to with pseudocode. So begin while. While the condition is true, so whatever that is, while attempts is less than 3 or whatever, execute something. Now that can be 1. I know this example has 2 in it, but that can be 1, or that can be multiple steps. However, once I get to here, what my while loop actually does is it loops back and it checks to see if the condition is still true. So if it was while attempts is less than 3, what I'd probably do is, allow a step to go, allow the user to enter the passcode again, add 1 to the attempts variable. So when I come back up to here, the attempts on the second loop around would be 1, and again, that's less than 3, so it'd allow the user to try again. And then I'd add 1 to the attempts variable again, so attempts would be 2, and then it'd allow me to loop back around and check it again. So this is a loop. This loop will continue to do that cyclical process until a condition is true or false, or until a condition is met. So, this is an example. You can have the condition is usually a variable that controls it, so while attempts is less than 3 or while attempts is true. I've just written is true. That is an example of something you can do, not necessarily just it. The things that you have to understand from the repetition control structure is the words while and end while. The condition is checked before you enter into executing the steps. I can have one or many steps and it'll keep on going around until a condition is met. The second type of repetition control structure doesn't check a condition before it actually executes a step. And I'm just going to jump out of here because this is actually indented at the wrong spot. I'm going to have to tab that along, and I'm going to have to tab that back. There we go. That's a little bit better. This is not laid out in the most perfect way, and I know that's probably bad, but work with me. A post-test loop checks the condition at the end. So it has something repeat until. It is a repeat until control structure. So you begin your logic, you just do the step. And then you check the condition, say, okay, you've done it, well done, keep on going until your condition is true. And so then it keeps on going, it does the process again, it repeats until the condition is through. Keep on going, keep on going, keep on going. But the thing that you need to understand with your logic, it executes the first round or the first iteration before it checks a condition. So unlike our friend while, which always checks the condition first, it actually executes it and then checks. So for something like, opening up, unlocking your phone, you definitely wouldn't want to repeat post-test or repeat until, because no matter how many times, your logic will always give you one free pass in order to be able to check, or in order to be able to unlock your phone. You definitely need to check that condition first. Where you might use a post-test loop, and again, this is like an anecdotal example outside of software. Some of you might have had, your teacher go, okay, keep on shooting the basketball into the hoop until you get to 20. You don't go, am I at 20? No, shoot the basketball into the hoop. No, you go, keep going. Okay, give it a go. Am I at 20? No. Am I at 20? No. Am I at 20? No. Am I at 20? But that you take that first shot knowing that you don't have to ask yourself that question. So that's a time where you use a post-test loop. A counted loop is really, really important. A counted loop is controlled by a counter, which sounds obvious, I know, but work with me. A counted loop says, okay, I know exactly how many times I wish to loop this particular part of pseudocode. So, or this particular logic. I know I want to loop a finite number of times. So it might be 10, it might be 7, it might be 3. I know exactly the number. I'm not waiting for a condition or a variable. I know exactly the number. I want a counter that goes from 1 to 25. Yep. And I want to loop this 25 times exactly. And then I want to break out. For that, I use a for next counter. Now, I know some of you are probably sitting here going, actually, that scenario Miss talked about with the pre-test loop, that could actually work with the counted loop as well. Actually, the more I think about it, it could work with a post-test loop too. I wonder which one is the best logic. And if you are thinking that right now, congratulations, very well done. You have worked out the key thing with logic, which is there are usually multiple ways to solve a problem. Most logic you can make fit a lot of different scenarios. You are looking for the animal farm number. So yes, there are logics that are correct, but there are some that are more correct than others. And what you're looking for when picking, okay, this is the type of control structure algorithm I'm going to use, is which one completes the task most efficiently. The way to find that out is test all of them and go, okay, I'm going to select counted loop for this, and this is why. There is not necessarily always just one right answer. There is not necessarily one logic that will solve the problem. You can usually in your head make multiple logics or multiple different control structures execute the same task. Some will do it more efficiently though, and that's what you guys need to work out. So for a counted loop, it's for a finite number of times. So you declare a variable called counter and you call it an integer, and you say, while counter is, from 1 to 10, execute this step, that could be 1 or multiple, and then go to the next counter. So what this next counter will do is it will increment. So if on the first iteration for the first loop I'm on 1, it'll then go to the next counter, which is 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it will break out of the loop. And that's it, guys. That's control structures.